So, thanks for being here. Today, we are here to present the paper that we were reading and we worked on it too. It's on discerning canonical user representation for cross-domain recommendations, which we can call Discuss CDR for short throughout the presentation. This research was done by Sikau Jha and Sherry Sahibi at the University at Albany. I hope the names are right. Let's get deep down into the presentation now. Introduction to cross-domain recommendation systems. Cross-domain recommendation systems, or CDRs for short, are designed to improve recommendations by pulling in data from multiple domains. For example, imagine you're on an Amazon and the system wants to recommend both movies and the video games too. By sharing information about what you like in one area, like your favorite movie genre, the system can give better suggestions for video games too. However, the CDRs face big challenges, like data sparsity is one of the problem, and the cold start problem, where the user is new and system doesn't have enough info about the new user. Existing models either push too hard on finding shared user interest or allow the two domains to drift apart too much. Now here, we are aiming to strike a new balance, nice balance. Motivations and objectives. The motivation behind Disco CDR is simple. We noticed a gap. The CDR models don't always distinguish well between user interests that overlap across domains, like someone liking action movies and action games, and those that are unique to each domain, like enjoying documentaries but not necessarily liking the simpler video games. Our objective is to capture these differences or similarities in a way that improves recommendations on both sides without them clashing. Think of it as a way to use knowledge from both domains without forcing them into the same mold. Let's discuss the overview of the Disco CDR model now. Let's break down the CDR model into two main components. First, we have Disco, a method that extends a canonical correlation analysis, discerning canonical correlation analysis as Disco helps us identify user interests that are shared between domains and those that are unique to each. Second, we use GANs or generative adversarial networks. GANs help the model learn and simulate realistic user feedback in each domain, like whether you're likely to click on a movie recommendation versus a game recommendation. By combining these two tools, we use balance, shared, and unique preferences to make much more accurate cross-domain recommendations. Now, further, we'll see what the key components of Discover or CDR are. Disca is one of the key innovations in Disca CDR. It builds on canonical correlation analysis, or CCA for short, which is a method for finding relation between two sets of variables. Imagine trying to find common grounds between what people like in movies and what they like in games. We do this by two objectives, as we can see here. One is LS, this loss function, which is shared preferences closer together. For example, if someone likes fast-paced action in movies and games, we want to capture that as a shared preference. Now, next we have LD, a distant representation. This is one, separates the unique parts of the each domain. So if someone loves documentary but isn't interested in slow-paced games, this is where we find this unique preference separate. Together, these objectives help Discuss EDR learn a balance between shared and unique preferences, preventing it from treating all domains the same and forcing both the domains to collide with each other. Next, we'll be discussing GAN model. How is GAN helpful in Discuss EDR model? Now, as we know, if you're familiar with GAN, you know they're like a game between two neural networks, a generator and a discriminator. Here, each domain, movies and games, for example, has its own GAN. The generator tries to create realistic user preferences, while the discriminator tries to catch fake ones. Each generator learns to produce feedback for each domain based on what it thinks the user would like. So the movie generator produces feedback for movies, and the game generator does the same for games. Meanwhile, each discriminator is constantly challenging its generator, pushing it to create more accurate predictions. This setup forces the generator to learn a lot about what users actually like in each domain. Now, as we can see, we have loss functions for this as well. Loss function for the generator and loss function for the discriminator. which in turn is a proportional to here we can see where the shared preferences is used. The generator is using the shared preference LS and LD, while here we are directly calculating for the known values are we are calculating RU based on R dash, and here we are calculating R dash based on LS and LD. Uh, this is how GAN is used in Discosedia model. Now here is the negative sampling strategy. A big issue in recommendation system is sparsity. Most users don't interact with each item. So if you're only training on the few items users actually click, we might miss the bigger picture. To address this, we use a technique called negative sampling. During training, we randomly sample some unobserved items, things the users didn't interact with, and label them as negative. Just like when you, I guess, when you scroll a reel and you don't interact with it, or the time you spend on a reel is very little. That's where the negative sampling strategy is also used, for example. This generator then learns to produce a high score for items users like, but a low score for things, negative items. This stops the model from just saying yes, the user likes everything, and makes it more accurate by forcing it to learn the difference between items users care about and those they don't. And here is a loss function for that. Now the model training process. Here's how it all comes together in training. The generators and the discriminators go head to head in a min-max game, while the discard component balances shared and unique references across domain. To prevent overfitting, we also use regularization terms in the loss functions. Negative sampling keeps the generator from defaulting to the easy answer, just saying that as we discussed, just saying the user likes everything and ensures it produces realistic feedback scores across both observed and unobserved items. This process helps the model learn nuanced patterns in user preference across different domains. Let's see how the experimental setup is done and evaluation metrics are used. We evaluated Discovedia using two popular datasets: Amazon, with domain like movies and TVs and video games, and Yelp, where we looked at restaurants and the shopping. For metrics, we use hit ratio, HR, NDCG, and the mean reciprocal rank, MRR, which tell us about how well the model ranks relevant items. We also use leave one out validation, a common approach for recommendation tasks that helps us evaluate the model's ability to predict the next item a user would engage with.
Coming to the results and performance comparison, here are the results. Discover CDR outperformed all the baseline models across metrics on both datasets. This includes both the single domain and cross domain models, showing that Discover CDR's balance of shared and distinct user preferences works well. We also did ablation studies to see how each component affects performance. Removing LSL or LDL caused a noticeable drop in accuracy, which reinforces the importance of modeling both shared and unique user interests. Our sensitivity analysis showed that tuning hyperparameters like lambda s, lambda d, lambda n, and omega is key to getting the best performance. We also wanted to see how Discuss CDR handles cold start scenarios, situations where we have little data on a new user or item. We divided users into groups based on their activity levels, from those with fewer than 10 interactions to those with more than 30. The model performed well even for cold start users, especially in Elp's shopping domain. This shows Discard CDR's strength in working with sparse data, which is crucial for real world applications where users might be new or less active on the platform. Now, coming to the conclusion, Discuss CDR is a new approach for cross domain recommendation that brings together Disca and GANs to balance shared and unique user preferences. This method enhances recommendation quality, especially in handling sparse data and new users. We are excited to take this further by exploring more domains and refining Disca for even broader applications.
Now for the future work breakdown, we'll be collecting data from in the campus of users. The data that we'll be collecting are the music, movies, and hobbies. And now we'll be using this since the movies will be sparse in data, music will get it from the Spotify playlist or something. Now The movies will be our cold start problem here. We'll have little to no data of the user. What we are going to do is we'll be using the music data to recommend the movies to the user. And also hobbies, we are going to collect the hobbies. Through hobbies also we'll be, I mean, obviously through hobbies also there is a lot of dependency on the movies. Let's say a guy loves to play cricket or something. We'll be using that data to recommend movies that are related to the sports kind of stuff. And that's the data that we'll be focusing on, and we'll be doing the same Desca implementation GAN integration here. We'll be using generator and discriminator to effectively train and produce and validate user feedback. And we'll be using negative sampling to actually know if a person is not interacting with in, here the negative sampling, I think it will be required in rating, I mean, music, listening, etc. If a genre is missing from a person, we shouldn't be like this is not interested or something. We'll be having a negative sampling for that. And evaluation metrics will be using the same hit ratio, NDCG, and MMR to access the performance of our model. And that's it. We'll be using Disk and GAN to experiment with this stuff. And hopefully we'll get better results. That's it. Thank you so. Thanks so much for your time.